Hi, everybody. So this is for our thermodynamics unit. We're going to do this kind of introductory lab that we're calling the energy and water lab. So thermodynamics, right? If you break that word down, thermo means heat, right? If you think about a thermometer, and dynamics means changing. So this unit here that we're looking at is all about the change in heat and change in heat energy. So we're going to start by using our most common substance, right? Water, measuring the heat change in water. So we have a beaker here with 200 milliliters of water, beaker here with 400 milliliters of water. And then we got these temperature probes. I'm just going to heat this one up with my hand. Yeah, that's temperature 1. So I'm putting temperature 1 in beaker A with the 200. I'm putting temperature, probe number 2 in the beaker with 400 milliliters of water. Okay, and then so we're going to get an initial temperature on those, and then we're going to heat these up to 40 degrees Celsius on this hot plate here, and see how that goes. So if we look at beaker A, it looks like we got an initial temperature of 22.3. Okay, so for number 1, it looks like we got 23.1. For beaker 2, we got 22.6. Okay, and then I'm going to crank this temperature up. So 23.1, 22.6 were our initial temperatures. So I'm going to crank the hot plate on, and that's on 1. This all the way up to 10. So we're going to crank this up. We're going to heat these up to 40 degrees and see which one heats up fast, or if they heat up at the same rate. Now for thermodynamics, we talk more in mass than we do volume. So volume, there's 200 milliliters and 400 milliliters, right? So if we wanted to draw a picture, we just draw twice as much. It's also going to be twice as much mass, right? Because there's twice as many water particles. So, but we want to also measure specifically the weight. Okay, and if we remember back, 1 milliliter equals 1 gram, specifically only for water. So water is good for this. So beaker A, the 200 milliliter beaker, you can fill in is also 200 grams. Beaker B with 400 milliliters of water is also 400 grams of water. Okay, so we're going to heat these up. We're going to see what happens when, again, they get up to 40 degrees Celsius, right? They're both on the same hot plate, so they're both getting the same heat input, right? And we're going to see, does one of them heat up faster? Does one of them heat up slower? Okay, or is it the same? And, we'll see from there. I'm just going to mix these up a little bit. Sometimes that helps a little bit. So we'll readjust from where that temperature was right now. But really, they started at almost the same temperature. I think it was beaker 1 here with the less water was a little bit higher, but it was pretty close. So we're going to assume they started at the same temperature, right? Even if we had a little bit different initial temperatures. Okay, and now we're just going to let these sit and go up to 40 degrees Celsius. Right, and then they've done on the hot plate. The hot plate's cranked up all the way. So those particles are moving faster, right, in the water. That's what we learned last unit. So the particles are moving faster, right, and that's what we're recording. That's what we're measuring here with the temperature change. And I'm just going to hold these myself a little bit so that they're not touching so that the temperature is not touching the hot plate. Okay, I'm just going to hold these up a little bit so that they're touching the middle. They're reading the middle of the water as opposed to the water that's right next to the hot plate. Okay, so that made a little difference, I think, too. Right, when the probes are touching the hot plate, it gets influenced by that's the hottest part. But really, the heat heats the water on the bottom. That water mixes with the other water to get the overall temperature of this whole sample. Okay, so again, temperature 1. Let's see, temperature. I'm going to break this up again. Temperature 2. is the one in my hand here. Temperature 2 is the one here. Temperature 1 is in the bigger beaker. So temperature 2 is here in the less water. So I'm going to stir one more time too. So what it looks like is happening is that the beaker here with less water in it has already got to 40, okay? Whereas the beaker with twice as much water has at 33. Now they're both going up. They're both going up at a pretty constant rate too. So we're heating both to 40, right? And I'm going to go ahead and take this guy off because it's already been there. So I'm going to leave that off. And then we'll keep heating this guy for another minute or so until we get there. Okay, and then once we get to 40 degrees, once we see these at the end of the video, you guys are going to try and answer those couple questions as to which beaker has more energy at the time that each one hit 40. So remember, this one, beaker 1, or the 200 milliliter beaker is already done gaining its energy and getting heated up. Beaker B, the 400 milliliter one, is going to stop right here. Okay, so that one now has it's been heated up to 40 degrees Celsius. Okay, so you're going to try and answer those couple questions there. And then you're going to also try and calculate. Okay, we give you some hints there on how to calculate what the change in heat was. The delta H, we call that, is the change in heat energy. Okay, so you guys are going to answer the questions. Try and get a number for how much heat energy each one of these two beakers gain. Okay, and then we'll look on to our second